We only have 5 people.
All right, folks. Can y'all hear me?
Yes, sir.
All right, let's get
Hello, everybody. I can hear you.
all right, rock and roll. All right, let's look at this exam here. This problem seems complicated at first, but it's really not. All right, an astronaut on the moon throws a baseball upward with an initial velocity of 10 meters per second, releasing the baseball 2 meters above the ground. The height of the baseball in meters is modeled by the function h of t. The same experiment done on Earth is modeled by a different h of t, where h is in meters. How much longer would the ball stay in the air on the moon compared to the Earth? Well, if we look at these two equations, we can see they both have a +2. So both the heights here start off at a height of 2. It's just the rest of this, let's see, the middle is the same, right? The only difference here is the A's. And it's because there's different gravity on the moon than on the Earth. So in each one, they're just throwing the ball, and we're seeing how long it would take for the ball to hit the ground. So if we look at the moon, they say h of t is this guy. So if we want to find out how long it takes for the ball to hit the ground on the moon, we set the height equal to 0, and then we solve for the time. And we do that with the quadratic formula. Then we'll just do the same thing with the Earth function. And then we compare. So the ball should be in the air longer on the moon than on the Earth. So for the moon, see, we have an A of a negative 0.81, B is 10, C is 2. So T is negative B plus or minus the square root of B squared minus 4AC all over 2A. So at first we have a 10 over, let's see, 1.62 plus or minus the square root of 100 plus, and let me use my calculator here. So I don't muck up the arithmetic. 4 times 0.81 times a 2. It's a 6.48 all over, this case, negative 1.62. So let's see, 10 divided by 1.62 is 6.17. This minus here, again, you can just throw it away, or you could choose to rewrite it as a minus plus if you want. It's going to be the same either way. So we have 106.48 and square root that. Now divide that by 1.62. We get a 6.37. So if we add these, we get a 12.54 seconds. And if we subtract them, we get a negative 0.2. The negative time doesn't make sense. So we can see it takes 12.54 seconds for the ball to hit the ground on the moon. Now on the Earth, we have a different height formula. It's negative 4.9 t squared plus 10t plus 2. So if we set that equal to 0, because we want to find out when the height is 0, when the ball hits the ground, we can solve this again with the quadratic formula. A, B, C. So time here to get negative b plus or minus the square root of b squared minus 4ac all over 2a. So we got a 10 over a 9.8 plus or minus 100 plus, better use my calculator, 4 times a 4.9 times 2. 39.2 over negative 9.8. So 10 divided by 9.8 is 1.02. I'll do a minus plus here. So now we have the square root, let's see, 139.2. We square root that. Now divide by 9.8, and we get a 1.2. So if we add these, we get a 2.22 seconds. And if we subtract them, we get a negative 0.18. Don't care about the negative time. So that's how long it's in the air on Earth. So we need to find the difference because they ask how much longer would the ball be in the air on the moon compared to the Earth. Well, 2.54 seconds minus 2.22 seconds. 12.54 minus 2.22 is a 10.32 seconds. All right, any questions about this? I know it's a long paragraph, but it's just,
Yeah, it took up like a whole page.
yeah, exactly. You know, sometimes simple things take up a whole page. No, it's just two problems like the old ones we used to do, just two of them in one. All right, let's look at number 2. The Apollo's Chariot is a roller coaster at Busch Gardens with a top speed of 117 kilometers per hour. Its initial and tallest descent can be modeled by h of t. H is in meters, t is in seconds. How long does it take to reach the bottom of the hill? Okay, well, when it's at the bottom of the hill, the height is 0, right? So same thing here. Here's our height function. We've set it to 0 because it's at the bottom of the hill when the height is 0. So we just solve for t. Here, since the b is 0, we can use the root method, the square root method. You can use the quadratic formula too. Either one will work. But let's go ahead and use the square root method. So we get a 4.9 t squared is equal to a 52. All right, we can divide both sides by a 4.9. We can square root both sides. This gives us the absolute value. All right, 52 divided by a 4.9 is a 10.61. So t is 10.61 seconds. Again, we're not concerned with the negative one. only the positive one here. That's how long it takes for the height to be 0. We just did a quick square root. And that's it for this exam.
I got a different answer for that one.
What did you get?
I got 3.26.
I think that's what I got last time.
That's what I got.
What I got too.
I think it was,
3.26 seconds.
What do we do wrong?
I don't know. Maybe I plugged it into my calculator. Yeah. I didn't do the square root. So square root, yeah, 3.26 seconds.
Okay, cool.
Yeah.
Okay, all right. I was scared.
Y'all did good. Thanks for paying attention. There we go.
I had to go back and watch your YouTube video to get the formula. I was like, wait. And I wasn't sure if I was supposed to graph it or not. I was like, no, I don't think this is a
It doesn't
graphable thing.
It doesn't hurt, right? I mean, what would this look like? If you plug in 0, you just have 52. So it starts here at 52. The A is negative, so it opens downward. So it might look like this, or it could look like this. It depends on where the vertex is at, right? If we look at the vertex, B is 0. So it turns out this is the vertex. So it looks like this, not like that. And since we found T here, we can see that this is at 3.26. So that's our graph. So yeah,
Okay, cool.
to graph something, you know, if you're having trouble understanding it, start off by graphing it. That visual aid always helps. All right, let's check out a quiz here. Looks like the answers are already here. Don't look at that. There.
No, sir. You can put them back up.
I hope somebody took a picture of that.
Right. You should have screenshot it. Darn it.
All right, so let me see. I forget what page these are from. Yeah, they're from page 137. So yeah, just use the square root method on these. And watch out for those square roots of -1s. So it's 311, take 15 minutes. So we'll do 325. Get your breakout rooms going. Okay, class, we are back. So let's knock out this quiz here. So using the square root method, let's subtract 81 from both sides. Divide both sides by 4. I'll square root both sides. So square root of x squared is the absolute value of x. The square root of 81 is 9. The square root of 4 is 2. And this minus inside of here gives us an I. So x is positive negative 9/2 I. Any questions? All right, number 2, same thing. We will subtract 20 from both sides. And we can divide both sides by 5. See, 20 divided by 5 is 4. So we can square root both sides. The absolute value of x, square root of 4 is 2, and that minus sign gives us an I. So x is either positive or a negative 2i.
So I have
Question.
a question.
Yeah.
So for number one, I did, like I wrote my answer, x1 equals negative 9/2i, and then x2 equals positive 9/2i. Is that, should I write it the way you wrote it,
No,
or?
that's fine. You can be like, okay, therefore, x1 is 9/2 I, and x2 is a negative 9/2 I. That's fine. You're just
Okay, cool.
labeling the two solutions as x1 and x2.
Okay, I just wanted to make sure that was cool for like homework or anything.
Yeah, that's fine.
Thanks.
All right, let's move on. And we left off on page 139, number 5. I got frustrated because I was trying to factor this one all the way, but you can't. All we can do on this one, we can pull out a 6. Right? If we try to factor this, it would look something like this. You might try to eyeball it and be like, oh, maybe I'll do a 5. Maybe I'll do a -5 and a +1. Let's see, that gives us, but that gives us a -5. This is a +5. So that doesn't work. You can keep trying combinations and nothing will work. Turns out this isn't factorable unless you use imaginary numbers. Basically, if you took this and set it equal to 0, use the quadratic formula, you would get i's in there, square roots of -1s. So what this thing would end up looking like, it looks something more like this. I'm not sure if this is exactly it or. Okay. So instead of having just a regular number, you got imaginary numbers. That might not be exactly it, but it's something like that. So this is the best we can do with it as far as just leaving it in terms of real numbers. So let's just move on to number 6 here. All right, all these numbers are divisible by 2, and they all have an x. Let's pull it at 2x out, see what we get. We got a 4x squared plus 6x minus 5. Is that right? Yeah. Now, maybe we can factor this. All right. That's not one that I can eyeball. So there's a trick to factoring stuff like this. I call it the PQ method. You can use call it anything you want. Basically, you take your A and your C, multiply them together. We get a -20. What we need 2 numbers. You can call them whatever you want. U and V, T and S. I call them P and Q. We need 2 numbers that multiply to give us A times C. But also we need to look at B. B here is 6. We need these same 2 numbers to add to be 6. And if we can find 2 numbers that satisfy that, we'll rewrite the 6x as like a 4x plus a 2x or something. It depends on what P and Q are. So if we look at 20, we can do what 10 and 2 doesn't work because they don't add to 6. 4 times 5 doesn't work. Let's see, 2, 4. Yeah, I don't think this works. I don't think this is factorable. So I think this is all we can do with this one. All right, so we'll leave it like that. Let's look at number 7 here. All right, this guy has X's, Y's, and Z's. See, those both have X's, these both have Y's. And these are both divisible by 5. So let's pull a 5x out of the first 2. That would give us a 3z plus a 4. 5x times 4 is 20x, yeah. Now for these other two, they both have y's, they're both divisible by 2. So that would give us a 3z plus 4. All right, notice this is the same as this. So what we have here is we have a 5x and a 2y, and they're both multiplied by a 3z plus 4. So that's a grouping. So you want to set it up where you get the same thing twice. So you can put those over here so you can get a factorization. Look at number 8. This one looks a lot like the last one. We got 4 terms here. But this one's x cubed, x squared, x, and no x's. Let's just see what can happen. These are both divisible by 6, right? And we can pull an x squared out. So 6 times a 4x, that gives us 24x cubed. And then a 6 times 7 is 42. So now what we want to do is look at this and see if we can get a 4x minus 7 out of it. That's what we want to turn it into, something times that. Well, if we're going to get a 4 out of 20, we're going to need to have a 5, right? 5 times 4 is 20x. And luckily, 5 times negative 7 is 35. So what we have here, we have our 6x squared and a 5, both multiplied by a 4x minus 7. So it works. This one works out. Let's look at number 9. We got x's and y's. See, these both have an x squared. These both have an x. Let's see this one here. Actually, you know what? We can pull a 3 out of everything. Let's do that before we do anything else. We'd have x squared y minus 2x squared minus xy plus 2. Anytime you can pull a number out of everything, you want to go ahead and do that. So now if we look at this stuff here in the middle, I'm going to use a square bracket here. These both have an x squared. We need a y minus 2. I'm missing an x right here. It should have been an x. So these both have an x. So if I pull out, let's pull out a negative x. All right, instead of a positive x. That way I get a y minus 2 again, because I want it to be the same. If I did a plus here, I would have this, and that doesn't work. So that's why I did a minus x, because minus x times a minus 2 is a positive 2x. And then I end my square bracket. So I have this 3 here. And this whole thing turns into an x squared minus x and a y minus 2. X squared minus x, y minus 2. So notice the use of square brackets. They're useful when you have parentheses inside of parentheses. You know, use your square brackets. Let's look at 10. All right. These all have x's and y's. These are both divisible by 3. These aren't. See, those are divisible by 2, but I don't know. This one has x's and y's. This is not working out. What I'm going to do is I'm going to switch these, because now I have x's together, and then I have my y's together. All right. Over here, I don't know about that. It might work out if I just tried factoring just numbers, but I like it better over here this way. That way, these I could pull an x out, you know, and I could pull a number out. These are both divisible by 10. So what I have is a 3x minus 2. And over here, I can pull a 3y out. And that gives me 3x minus 2. So I got a 10x and a 3y, both being multiplied by a 3x minus 2. Of course, we can check our work, right? We multiply it out. If we multiply this out, we'd get a 30x squared minus 20x plus a 9xy minus 6y. Is that what we have? Minus 6y, a minus 20x, 9xy. Yeah. So that was our checking our work. And we get what we should have gotten back. So that's correct. Oh, there's 2 more. Okay, we got some bigger numbers here. Let's have x's. This is x and y. Let's do that switcheroo thing. Let's switch these so that I got 2 things with x's. And now I got 2 things with y's. So here I know I can pull out an x. And okay, 56, what's 9 times 7, 56? It is, right? So if I pull a 7 out, to do that, that would give us the 56x squared and then a 10. Over here, I want to end up with this again. But to do that, let's see, 9 times 3 is 24, right? I need a 3y here to get that, and yeah, and that gives me my minus 30y. So I have a 7x and I have a 3y, both multiplied by a 9x minus 10. Any questions? And again, we can multiply that out to check our work. Let's look at 12. Okay.
Wait.
Yeah.
9 times 6 is 54, not 56.
What's 9 times 7?
63.
63. Well, hell. All right, let's try it again. Is 56 divisible by 7? 56 divided by 7 is 8. 8 times 7 is 56, right? So if I pull the 7 out, I need an 8. I need an 8 here. 8 times 7 is 56. And then over here, this would be the same. I want an 8x minus 10. So I need a 3y here. 3 times 8 is 24xy minus 30y. So yeah, we got a 7x plus a 3y times 8x minus 10. Thank you. Yeah, see, you were there. Otherwise, I should have checked my work because I wouldn't have ended up with the right answer, right?
Yeah, sorry. I had to look it up just to be sure. 100%. I'm like 9 times 6. I think that's 54. I'm not sure.
No, that's perfect. That's what y'all need to be doing. I guarantee my 10 o'clock class wouldn't have caught that. It's too early in the morning. All right, let's look at 12 here. I'm thinking because these have y's, we should put those together. And then have these. These both don't have x's, but at least these both have y's. Let's see, over here we can get a y out of there and a 2. That'd be a 4x minus 5. So we know we want a 4x minus 5 again if possible. Turns out we can do a 3 here. And it works. All right. Sometimes these things aren't factorable. Like these are, you know, hand-picked problems that work out. So if you don't know if it's going to factor or not, I'd start with this and then see if it works, you know. So we have 2y and 3, both times a 4x minus 5. All right, page 140. Now they want us to factor them completely. Okay. Well, I have two methods here. The first method is eyeball method. I know it looks like that. I know I need an X and an X. I need two numbers to multiply to give us 8, but add to give us a -6. So in this case, it would be a -4 and a -2. They multiply to give me a +8, but the -4x and the -2x will add to give me the -6x. So typically, if there isn't an A, if A is just 1 over here, typically you can eyeball it. But if you can't, there's this other method. I call it the PQ method, but you'll never find that on the internet. They say take A times C, in this case it's 8, and then look at your B. Your B is -6. We want two numbers, I'm going to call them P and Q, that multiply to give us the same as A and C, but add to give us the same as B. So in this case, if we look at all the possibilities, 8s and 1s and 4s and 2s, and of course -8, -1, -4, and -2. The only ones that work here are this one. If we multiply those, we get 8. If we add them, we get -6. So let's let P be -4 and Q be -2. Now, what's the point of doing this? What you do is you look at B here. You rewrite B using these two numbers. Instead of 6x, we write it as a -4x minus 2x. That's the whole point of finding these two numbers. And now it's one of those older problems. Here we can pull out an x, and we get an x -4. And here we can pull out a -2, in which case we get an x -4. So we got an x and a -2, both times an x -4, which is the same thing we have up here from eyeballing it. So I'm going to go ahead and do this method even on the ones that we can eyeball, so that we get comfortable with this. So when the harder problems that you can't eyeball it, we'll have this method down. Okay. All right, 14. Let's see if we can eyeball it. Now I need an x and an x. Two numbers that multiply to be -15, but add to be -14. Probably -15 and 1. That gives us -15. -15x plus x gives us a -14x. So that's our factorization. Well, let's say we couldn't do it in our head. A times C here is -15. We need two numbers that multiply that give us that. B here is -14. So our two numbers need to add to give us that. So if we think about it, we could do P is -15 and Q is +1. They multiply to give us that. They add to give us that. So what we do is we rewrite -14x as a -15x plus an x. Then we factor the first two, we get an x -15. And then over here, we want to make it look like this, right? So what's our number? Well, this is the case where it's just 1. This is the same thing as that. You might look at it and say, there's nothing to factor out. You can always factor out a 1. Okay, so don't let this stump you. Because what this does, we got an x and we got a 1, both multiplied by an x -15. Okay, so if you see the factor you need just sitting right there, rewrite it like that. And again, it's the same thing we got up here. Let's look at 15. can we eyeball this guy? See, we need an X and an X. This is negative, so we're gonna need to have a positive and a negative. This is positive, so see 28, what, 7 times 4, right, makes 28? 7 and a 4, so if we did a positive 7 and a negative 4, that'll work. There's our negative 28. 7x minus 4x gives us our 3x. So that works. But if we couldn't eyeball it, we'd do this. We'd say a times c is negative 28. We need two numbers that multiply to give us that. Our b here is 3. So we need two numbers that add to give us that. So if we think about it, we might come up with a p being 7 and a q being minus 4, because they satisfy this. So what we do is we take the 3x and rewrite it as 7x minus 4x. So here we can pull out an x. And over here, we could pull out a minus 4. Did I do that right? Yeah. So we end up with an x and a minus 4, both times an x plus 7. Which is the same thing we got up here by eyeballing it. All right, this guy, x squared, and then a 9 is positive, but this one's negative. So we know we need two negatives here. And a 3 and a 3 will work. Negative 3 times negative 3 is positive 9. Minus 3x is a minus 6x. But since these are the same thing, we rewrite it like that. Okie dokie. But let's say we couldn't do it by eyeballing it. All right, our a times c here is 9. And just to show you, you don't have to call it p and q. Let's call it s and t. B here is negative 6, so we need two numbers, call them whatever you want, that add to give us that. So if we let s be negative 3 and t be negative 3, they multiply to give us 9, they add to give us negative 6. So we take our minus 6x and rewrite it as a minus 3x minus 3x. So here we can pull out an x, and here we can pull out a minus 3. So we got an x minus 3, both times an x minus 3, which is x minus 3 squared. Another way we could do this what if we set this equal to 0 and solve for x? If we use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. You know what answers we would get here? We would get negative 3 and negative 3. Those would be the two answers we get. No, actually, positive 3 and positive 3. Those would be the two answers we get from the quadratic formula. When you know your roots, you do x minus and then x minus. Why is that? Because setting this equal to 0 would be the same as setting this equal to 0. If this is exactly the same thing as that, these are identical equations, same equations. Remember, when you typically you factor whenever you're trying to solve for x, because what you do here is you take each factor and set them equal to 0, right? So here's something, x minus 6x plus 9. All right, we saw that this is x minus 3 squared. All right. These are the same thing, identically equal. I'll do like extra equal. Now, if we set this equal to 0, either one, x is 3. What if I multiplied here everything by 2? Right? These are not the same thing. This is twice as much, right? But if I was solving this equation, my solutions are still going to be exactly the same. Because if this was equal to 0, if I divide both sides by 2, this goes away and I'm left with the exact same thing. So factoring, I missed my squared. If I factored this versus factoring this, these both have the same solutions if I set them equal to 0. But this is going to be that, whereas this one is that. There's just an extra 2 on there. Okay, so these things are related, all right? If I set this or this equal to 0 and solve with the quadratic formula, I get this twice, right? But factoring this isn't the same as factoring that. There's this extra 2 in front, all right? So you can use the quadratic formula to factor things for you, because when you get your roots, you just do x minus root times an x minus root. That's your factorization. But that only works if a is 1. If it's not 1, you have to multiply everything. You have to put your a out here. We might have to do that later. Some of these don't work. All right, let's look at this one. I cannot eyeball this. I don't know, maybe I can. If I try a little harder. -10, so I need a plus and a minus. 5 and 2 work, right? -10, 5x minus 2x is 3x. So there we go. So let's do our little trick here. A times c is -10. So we need 2 numbers to multiply to give us that. B here is 3. I need my 2 numbers to add to give us that. So I let P be 5 and Q be -2. That's satisfied, that's satisfied. So I'd rewrite 3x as a 5x minus 2x. Here I'll pull out an x. Here I'll pull out a -2. All right. Yeah. So I got an x and a -2 both times an x plus 5. Same thing I got up here. Let's look at this one. Let's see if we can eyeball it. We need an x and an x. This is negative, so I need a positive and a negative. 5 and 3 multiply. 5 and 3. I need to make the 5 negative, so I get a -5x plus 3x gives us the -2x. But if we couldn't eyeball it, we could use this tool here. A times c is -15. 2 numbers that multiply to give us that. B is -2. Our 2 numbers need to add to give us that. So if we think about it, all the possibilities, what, -15 and 1, -3 and 5, -5 and 3, and so on, and then find the ones, we would find that a -5 and 3 works. Satisfies both of these. So we would rewrite the -2x as a -5x plus a 3x using these. So here we'll pull out an x. Here we'll pull out a 3. X minus 5. Both these things are multiplied by an x minus 5. Why do I have different answers here? 5 and 2. I screwed up over here. No, oh. We're not working on that problem. We're working on this problem. Those are the same thing. All right, number 19. This one, let's try to eyeball it. Well, first off, there's numbers in front of all of these things. So let's see if we can simplify this. First thing you want to do is see if you can get a number out of there. 7 times 6 is 42, and 7 times 5 is 35. So now I'll try to factor this with that 7 pulled out. I need an x and an x, positive but negative, so I need 2 minuses, and a 5 and a 1 ought to work. Minus 5x minus x is a negative 6x. So that's what we have here. We could do, if we couldn't figure this out, we do our a times c. Here a is 1, c is 5. B is negative 6. And if we thought about it, we would come up with P being what, minus 5, and Q being a minus 1. They multiply to give us 5, but add to give us negative 6. So we'd keep our 7 here, use some square parentheses. We have our x squared, take the minus 6x and rewrite it as a minus 5x minus x. So out of here, we'll pull out an x. Out of here, let's pull out a minus 1. So we can rewrite that as an x minus 5. So I still have my 7. This stuff here turns into an x minus 1 times an x minus 5. Okay. If I did my quadratic formula, and I did my x equals, if I did it here, I would have an a of 7 and b is negative 42 and so on, right? And a c is 35. If I used these numbers, all right, I would get x to be 1 and 5. But if instead I looked at this and I said, oh, a is 1, b is negative 6, and c is 5, if I use the quadratic formula with those a's and b's and c's, guess what? X would still be 1 and 5. The reason is because if I set that equal to 0, it's the same thing as setting this equal to 0. Because I would, first thing I'd do is divide both sides by 7. That would go away, and this is still 0. They have the same solutions, right? So if I'm factoring, let's see, I got 7x squared minus 4, 2x. That versus this guy, all right? Setting these equal to 0, they give me the same solutions, 1 and 5. I know that this, because I know the solutions from the quadratic formula, this would be an x minus 1 times an x minus 5. This gives me the same solutions, but these are not equal, right? This is 7 times this stuff, right? So if you're going to use the quadratic formula, all right, pull out this first number, factor it out, do the quadratic formula on that, because you don't know, you'll get, once you get your roots, you just do x minus each root, all right? Get 20 here, do this last one, and then we'll take a break. Here, everything's divisible by 3. Let's pull a 3 out. Now let's eyeball. I need an x and an x, This is negative, but that's positive, so I need two minuses here. And let's see, 4 and 2 would work, right? Is that right? No, this is negative, so one of these has to be positive, one has to be negative. Because a positive times a negative gives me a negative. So I could do a positive 4 and a negative 2. And that should work. If I couldn't figure that out, I would do A times C is negative 8. B here is 2. So looking at these, I would think, okay, P is 4, Q is negative 2. Those multiply to give me a minus 8. They add to give me a 2. So I would rewrite this 2x as 4x minus 2x. I pull an x out of here, x plus 4. Pull a minus 2 out of there, and that gives me an x plus 4 again. So I get an x minus 2, both times an x plus 4. Same thing I had up here. So let's take a break. When we come back, we're going to deal with problems where there's an a here, like number 21, there's a 6x squared. And I can't just eyeball that one. So that ACPQ stuff is going to come in really useful when we get back. So it's 4:05. We'll come back at 4:20. All right, class, and we are back on page 141. Let's look at number 21 here. So if I looked at this and tried to eyeball it, I'd be like, I need a 6x squared, maybe a 3 and a 2. But now I need a minus 2 over here. So maybe I need a plus and a minus. But do I put the minus or the plus here? Gets complicated. Well, what if I did this? I'll factor out a 6. And then I end up with this. Trying to factor this guy. And I don't want to deal with fractions. It's kind of a pain in the butt, right? So let's do our A times C is negative 12. We need two numbers that multiply to be that. B here is 1. So our two numbers need to add to be that. So if we think about all the numbers that give us a negative 12, let's just think about 12. We got 12 and 1, 2 and 6, 3 and 4. All right, with one of these being negative. How about this one? If we did a positive 4 and a negative 3, they multiply to give us negative 12, they add to give us 1. So what we'll do, we'll take this plus x and rewrite it as a 4x minus 3x. Okay. We could do it either way. We could do minus 3x plus 4x. It doesn't matter which order you write them in. So now we could pull out a 2x out of the first two terms. That would give us a 3x plus 2. And then over here, if we pulled out a minus 1, we'd have 3x plus 2 again. So we got a 2x and a minus 1, both times a 3x plus 2. And of course, we can multiply these out to check our work here. So that's why this is useful. You can't always eyeball them. So let's look at 22. See, I can't pull a number out of all of these, so let's just go with what we know works here. A times C here is 40. So we need two numbers that multiply to be 40. B is negative 14. So our two numbers need to add to be that. And if we think about 40 here, I don't know, we got 40 and 1, but they're not going to work. They're not going to add to give us 14. We got 20 and 2, not divisible by 3, 4. We got 10 and 4. That should work, right? If we have -10 and a -4, they multiply to give us 40 and add to be -14. So I'll take this -14x and rewrite it as a -10x minus 4x. I'll pull a 5x out. I'll get an x minus 2. And over here, I pull out a -4. I got an x. Wait a minute. Yeah, -2. No, that would, okay, it's a positive here. Now it works. So I got a 5x and a -4, both times an x minus 2. So we get 23. I can't factor a number out here. Let's do a times c here. A is 9, so I got a -90. B here is 9. So see, I could use 90 and a 1, 45 and a 2. That's not going to work. 30 and a 3. 90 divisible by 4. I don't think so. Maybe it is. Let's see. 90 divided by 4. No. 5. 90 divided by 5. 5 and 18. So we could do an 18 times 5. What about 6? 15. So 15 times 6. That's probably the one we want there because their difference is 9. We let P be 15 and Q be -6. Those multiply to give us -90. They add to give us 9. So take 9x, rewrite it as a 15x minus 6x. Here we can pull out a 3x. And over here we can pull out a 2. So we have a 3x and a -2, both times a 3x plus 5. All right, let's look at 24.
So real quick on the last one, how did you get 90?
90, a times c. A is 9, c is -10.
Okay. Cool, thanks.
Sure. All right, this one, our a times c. 9 times 7. What is it, 63?
Yep.
All right.
9 times 6 is 63. Sorry, y'all, I have a lisp.
All right, our b here is 16. So let's see, 63. We already know 9 times 7 gives us 63. And it turns out if we add those, we get 16. But one of these has to be positive, one of these has to be negative, right? To give us a -63 here. So I think there is a problem with this problem. I don't think this one is factorable. Because think about it, if I made a -9 times a 7, they multiply to give us a -63, but there's no two numbers that I can think of that you can multiply to give you a -63, but add to give you a 16. All right, let's, if I do the calculator, 63 divided by 3, well, we could do 3 and 21, but that's, 21 minus 3 is 17, not 16, right? It's not divisible by 4 or 5. It's not divisible by 6. 63. We already did the 7. 8, 9. There's the 9. 10, 11, 12. 17 is divisible by 17. No. 19. No. Yeah, this method isn't going to work here for us. All right. That's because this only works for whole numbers. So what I'm going to do is I'm going to say, okay, what if I set this equal to 0 and I solved using the quadratic formula? Okay, mind you, this is also equal to 7 times x squared plus 16 over 7 minus 9 over 7 x. Okay, I divided both sides by 7. All right, so the solutions to this are the same as the solutions to this, but I'd rather use a, b, and c from here than all these ugly fractions. Okay, so let's see, if we did a, b, c, all right, x would be negative b plus or minus the square root of b squared minus 4ac all over 2a. So before I do this, I'm going to use Wolfram, and I'm going to tell you what this thing is factored, so we can compare what we get with the quadratic formula here. So if I just plug this in, let's see, 7x squared plus 16x minus 9. Let's see. Forgot to type in factor here. Factor. It's giving me ugly numbers. It's telling me this thing is negative 1/7 times a minus 7x. Let me write it down here instead. Negative 1/7 times a minus 7x plus the square root of 127 minus 8 times 7x plus the square root of 127 plus 8. All right. If I brought this 1/7 in, well, we can leave it out there. Let me write this in a different way. This would be, let's see, if I pulled the 7 out here and a 7 out from here, this would be a negative 7 times an x minus square root of 127 minus 8 over 7 times an x minus negative 127 minus 8 minus over 7. All right, that's what the computer says that it is. If I do this quadratic formula, what I'm going to end up with is the square root of 127 minus 8 over 7 and the negative square root of 127 minus 8 over 7. All right, these two numbers. Okay, so that's what we get if we use the quadratic formula. All right, so we could look at this and say, okay, here's our roots, and you can write down this. But this is left out, okay? Actually, this should be a positive. Did that quickly, so my minus signs are kind of off, because see, there's a 7 there. If you just multiply these together, you get an x times an x is an x squared, not a 7x squared. All right, because solving this is the same thing as solving this. The guy where we divided 7 out of everything. Same solutions. So if we were just factoring this, all right, this would be our factors, but we're not. We have 7 times that. So that's why there's a 7 here. So when they give us problems that you can't solve in the standard way, this is generally where you learn the most, whenever the textbook makes a mistake if you explore it. So if you're doing this, if you're trying to factor that, you could set it equal to 0, use the quadratic formula, and you'd get x equals +1 and +1. You get that twice if you use the quadratic formula. And looking at that, you could say, make this 2. No. Hold on. Yeah. You could say, okay, x minus 1 times x minus 1. In this case, yeah, that does need to be negative. All right, if I was trying to factor that, I could use the quadratic formula. I would get that. I just do x minus each one of those. So this is the same as this. But what if I had multiplied all this by a 2? If I just did this, I would just get this. I'd have to realize that I'd need to bring that 2 down. All right, you won't get any problems like that, so you don't have to worry about it. Let's move on with the problems that are cookie cut just right. Okay, we can't factor a number out. We can do our trick here. 9 times 8 is 72, I think. B here is 6. So 2 numbers that multiply to give us 72, but their difference is 6. About 12 and 6. Well, if we did P to be negative 12 and 6, not 6, P to be 6. I mean Q to be 6. They multiply to give us negative 72. They add to give us, I need to switch these, right? This one needs to be, that one needs to be positive. Now they add to give us 6. So I'll take this 6x and rewrite it as a 12x minus 6x. And now I'll factor out of here a 4x. I'll factor out of here a minus 3. So I have 4x and a minus 3, both times a 2x plus 3. Get another one here. I can't factor a number out. A times C is 70. B here is 19. So 2 numbers that multiply to give us 70, but add to give us 19. 12 and 5, right? 12 times 5 is 60, isn't it? So that won't work.
Yeah.
All right. Well, let's look at other options here. 70, we'd have what? 2 times 45. That doesn't work. Is 70 divisible by 3? No. Divisible by 4? No. It's divisible by 5. 5 times 14 gives us 70, and they add to be 19. So let's do P equals 5, Q equals 14. So let's rewrite 19x as 5x plus 14x. So here I can pull out a 5x, get a 2x plus 1, Here I'll pull out a 7, negative 2x plus 1. So I got a 5x and a 7, both times a 2x plus 1. What happens if I had to switch these? What if I had to instead wrote 14x plus 5x? Right? Would it still work out? Well, let's see.
No.
If I pull the 2 out of here, a 2x, I get a 5x plus 7. And this is 1 times 5x plus 7. So I got a 2x and a 1, both times a 5x plus 7. Same thing I got here. So it works out either way. Doesn't matter which one you call P or which one you call Q. Can't factor out any numbers. A times C is a negative 6. B here is a negative 5. So let's see, what if I did a negative 6 and a positive 1? That works. So we'll rewrite our minus 5x as a negative 6x plus x. So here we could pull out a 3x. And this is the same as 1 times an x minus 2. So I got a 3x and a 1, both times an x minus 2. Try 28 here. A times C, 12 times 6 is 72, right? And B here is 1. So what I can do, what, 9 and 8? 9 times 8 is 72, right? If I do 9, negative 8. So I can rewrite this as 9x minus 8x. So here I'll factor out a 3x, so I need a 4x plus 3. Here I can pull a minus 2 out, so I get 4x plus 3. So I got a 3x and a minus 2, both times a 4x plus 3. And I think that's where we left off in my last class. So that'll be it for the day, folks. Let's get you your exam here. So from page 137, just using the root method, we get these two problems. This should be pretty easy. And that's it for today. I will see y'all on Wednesday.
When you said we could use the root method,